Okay with recording, so just for the company policy piece, and we'll kick on with it. So I guess first thing we'll start with is just while we're all here, got a couple of Raspberry Pis up for grabs. I just specifically chose the one with the cooling, so that way they run a bit better, they're not as hot, and they're ultra quiet too, so you can use them as a home server or whatever you want. So to win one of these, the first one is under a quiz. So you just got to answer the questions on the quiz correctly, and you go on the draw. And the second one is a survey just about today's training. So good or bad feedback in the survey, you're still going to go on the draw. It's just a matter of filling it in, and you'll go on the draw for it. So just a couple of things around that. The winner must be based in NZ and not work for Ingram or Red Hat. Although we'd love to be able to give our own colleagues free stuff, we're not allowed to. So sorry if anyone from Ingram or Red Hat's on here. If multiple people answer the quiz correctly, the winner will be drawn from a hat. And for those who complete the quiz and the survey, basically we draw from the hat. We'll do it around noon tomorrow just to give people time to complete them. So just so that everyone is aware of what we actually do, we'll give a number to everyone that answers the quiz correctly, and then we'll use a random number generator to pull the winner out of that. And then we do the same thing for the survey. So it's completely fair and unbiased. It's just a number random system if you answer the quiz correctly. So. Cool. So I guess we'll crack on with the content. So today we're going to cover off just some basic information around Red Hat and OpenShift, just for those who might not be as familiar with it. And then we'll jump into an introduction to Windows containers, technically how they work, and then just talk about a little bit about .NET workloads and how they work with OpenShift. We'll talk about the competitive differentiators with OpenShift versus competition. So some of those key, I guess, competitive areas that OpenShift sit in. Then we'll do the quiz. We'll take a quick look at the roadmap and the future for OpenShift and Windows containers, and then I'll jump into a quick demo, followed by at the end there we'll do the survey. Cool. So Red Hat and OpenShift. So I guess OpenShift is the Red Hat's play in the container space, that cloud native application and modern development processes. So looking at things like microservices, AI, machine learning, web servers, and being able to scale at, with like the other Kubernetes and container providers do. So just in terms of Red Hat's three pillars of business, I guess there's three areas that Red Hat kind of sit in, and that's hybrid cloud infrastructure. So looking at being able to, scale and securely and manage all your traditional and cloud workloads across all environments, whether it be bare metal to on-prem or on cloud. You've got cloud native developments. That's just really about that whole development stack and pieces that can assist with development, whether it be middleware, runtimes, process automation. It's really that piece around building applications that are cloud native to begin with, so you can move it anywhere you want and it still runs the same. And then you've also got the management and automation piece. So that's just around automating environments, different cloud infrastructure. So today, I guess where we sort of sit with this one is more in that hybrid cloud infrastructure and cloud native development space is more around what this conversation is. So creating value depends on the ability to deliver applications faster. Obviously, one of the biggest drivers for any business is to be able to get products to market quicker. And I guess that's where Red Hat's trying to really push this, is that, from a business idea to actually implementing it and deploying it, that's kind of where the Kubernetes and container space is. And as we said before, it's looking at those cloud native apps like your AI, machine learning, analytics, IoT. And I guess the other one is innovation culture too. You can have all these tools at your disposal, but if you haven't got buy-in with your people, it's never going to work properly. So I guess Red Hat's very much about culture of development and building things for developers as well. And obviously, from Red Hat's perspective, OpenShift's the best platform to deliver container-based applications. You look at it, a platform that's built for developers by developers. So it's very much about that ability to scale up quickly and having everything, all the tools at your disposal, built into the Kubernetes platform, as opposed to just having bare metal or bare Kubernetes and having to build the platform around it. Red Hat kind of offer you the full package with OpenShift. So Kubernetes is the container orchestration standard today. 5 years ago, there was Docker, Mesos, you had Kubernetes starting out there as well. And I guess from where that was then to where it is now, Kubernetes is everywhere. So as you can see on the right there, you've got all these different vendors that are now purely basing their products on Kubernetes, and the other orchestrators are kind of being left off to the side. Not as big a conversation anymore, or at least they're still playing catch up to how fast Kubernetes sort of implemented after Google released it. So. trying to do Kubernetes yourself is pretty hard. You've got so many different pieces that you've got to think about when you're building up the platform and the environment. You got your installs, your templating, your validation, your OS setup. You've got your deployment, all your security pieces around the images, storage, and persistent. All your logging that you need to be able to do as well, and then being able to harden that on top of deploying all that. Then you've got to harden everything as well. It ends up becoming a pretty big job to get the same sort of platform that OpenShift delivers out of the box. And then from the operations side, it's all those upgrades and patches and things that, log aggregation and alerts. It really is a big beast to tame, and that's where Red Hat has kind of taken all those pieces that you need and built the platform from scratch. Obviously, there's still things around different security policies and things that you've got to do with OpenShift to make sure it's safe, but everything's there built into it as part of the platform. You're not kind of bolting things on to build it up yourself. And there was also a study done by the new Stack, which said that 75% of enterprise users identify complexity of implementation and operations as a top blocker for adoption of Kubernetes. So really, it is a complex beast to do, and it can stop people actually rolling out and actually using it. So Red Hat's all about doing all the hard work for the customer or the people that are actually going to use the platform. So when you look at the cloud native computing foundation landscape, there's so many different pieces here, whether it be the orchestrator to the actual container runtimes and things. That there's a lot of different pieces that all make up a cloud native platform, and any CIO or CTO is going to go and have a look at this and just think, man, there's too much there for me to go and do myself. And that's where you get these Kubernetes implementations like Red Hat's and even the cloud native ones that you get from your AWS and your Azure is taking these pieces and building the platform for you. So I guess Red Hat kind of sits in the same space, except Red Hat's talking about a platform you can host anywhere, which we'll get into in a minute. But yeah, it's pretty mind-boggling. So you can actually go and have a look at that website on the so I guess l.cncf.io, and you get that page come up, and you can spend hours just looking through everything that's on there, just trying to understand what each one of them is. So it's quite impressive actually. So I guess the question is why do customers choose Red Hat OpenShift? Red Hat takes the best of all the open source cloud native projects that are out there, builds them into the OpenShift platform. So they either come as standard or you can bolt them on via an easy installation step, which is part of the interface as well. So it takes that trusted enterprise Kubernetes, allows you to then have that cloud-like experience anywhere for your building of your applications and hosting. And then it empowers developers to innovate as well with things like Quarkus and Spring Boot, the support for it within OpenShift. It means you can really build those performance and light applications that you need from a container perspective. And then built into the platform, you're looking at things like serverless, so being able to scale all your nodes to zero when they're not in use. So containers to zero instead of always having one running. You can really limit how much resource you use when the container isn't actually used. To things like service mesh, being able to have all your microservices and things all built in together. So Red Hat's really, as we said, is all about taking those projects and trying to pull them all into one single platform. So with OpenShift, you can consume it how you like. OpenShift can be run on all the major cloud providers, with some of them actually offering it as a managed service. So the likes of Amazon and Azure now provide it as a managed service, same with IBM Cloud. But you've always got the option to still do your own version of it running on those platforms as well. And I guess the advantage of OpenShift is that you're not tied into the processes of each cloud provider's native Kubernetes service. They all offer their own Kubernetes, but you're tying into their version of it. With OpenShift, developing and building containers creates a standard process, and it makes it easy to lift and shift to another cloud or run it across multiple clouds as well. So that's the true benefit really of OpenShift. And with all the pieces built into the platform, it becomes its own cloud platform. So even though you might be hosting it on a cloud provider, it's actually a full platform you can use as your own cloud essentially with the way that it's structured. So let's jump into the Windows containers. So I guess with why you run Windows containers, the Windows presence these days, it's still significant out there. There's still a lot of .NET and Windows applications that are out there. So the idea there being that you're kind of coming to the table to allow a way for those legacy or those existing applications to still be able to run alongside your cloud native stuff. And then you're co-mingling it with your Linux ecosystem, so you're running Windows containers side by side with your Linux containers. Your .NET app development, it continues, and it's been used widely for application development, around the world. So it's still a major player that's out there. And it's really about embracing that microservices architecture that everyone talks about. It's not always the right way to build an application, but these days you find it's a lot easier to scale when you're building them smaller and iterating. So yeah, why Red Hat OpenShift Windows containers? I guess you realise the benefits of the ability to port the applications, the speed of them, and the flexibility using the platform. Different ways to deploy, different ways of scaling your applications as well. And then you can support those legacy workloads efficiently, modernize them at the same time. So the idea being you can be hosting your legacy applications while also building more modern applications alongside them, or porting them, or refactoring them. And you get increased developer productivity. So you get exposure to Kubernetes without having to rebuild applications. So you can get your developers kind of halfway there, and then they can start using the full platform as part of their development process. So introduction to Red Hat OpenShift. So really the way that it works is you've got your low level kind of infrastructure. You've got your physical, your virtual, your cloud, where you manage cloud. And within that, then you can run on top of that, you can run nodes, which essentially run the platform. So in this case, we're talking the core, or the base platform for OpenShift is Red Hat Enterprise Linux CoreOS. So on the side of that, as a data operation, you can just deploy your Windows Server nodes to run those container workloads that are Windows native. And then over those nodes, you've got your Kubernetes platform and all your services. And then you've got your things like service mesh built in, your application services, and then your developer pieces too. So your command line interfaces, your Visual Studio Code extensions, IDE plugins, and all the rest. And then over top of that, you've got multi-cluster management abilities now as well, with things like Red Hat Advanced Cluster Management. So you can be managing multiple instances of these clusters all around them, all over the place through one centralized interface. So you can do those deployments of your applications, concurrently across multiple different clusters. So mixed Windows and Linux workloads running together on OpenShift. So really, there's kind of two, or I guess three in this case, modes that you've got. You've got the ability to, if you're hosting on bare metal, is actually running Windows virtual machines. So that's where you can actually use OpenShift virtualization to run a VM on the platform itself. You've got the Linux containers, which are baked in. So that's where you can be running Linux containers with all your other different types of code and programming. Or you've also got the ability to run .NET Core containers, .NET Core being the cross-platform implementation of .NET that Microsoft has. And then you've also got Windows containers now as well. So that's where the platform can support your traditional .NET framework, which doesn't support cross-platform as well. But also .NET Core obviously runs on Windows, on Microsoft's own products as well. So it kind of gives you all of those three options with the platform, depending on where you want to go with it. I think you're on mute. Oh, apologies. Sorry, I didn't unmute myself after I had a drink. Thanks for that. Yeah, so I guess the question is Windows containers or virtualization. So obviously you're looking at rehosting, so you're moving your virtual machines from your current hypervisor into the OpenShift platform with the goal of modernizing those applications over time without having to rebuild them. So you can pull them in as virtual machines and then slowly pull off pieces of them all within the same platform, building them more as a cloud native type application. Or you can look at refactoring. So that's taking your traditional .NET applications and deploy them, to Windows nodes on Red Hat OpenShift. And that's where, depending on which type of application the customer's developed, whether it be .NET Framework, you can run them directly as Windows containers, or if it's .NET Core, you can obviously run them cross-platform as well. So use cases for Windows container workloads. So really, you've got that rehost, which is using the virtualization. You move your virtual machine. It's easy and low friction. There's not as much risk to the end user or to the customer for their workloads. I guess the trade-off is you've got no benefits of containerization. You're literally just sort of moving it from one to the other. But the advantage is you now have it in the same platform as you're building your modern applications. You've got the ability to refactor. So that's where you're taking OpenShift support for Windows containers, containerizing your .NET Framework apps. And then really your trade-off is you're evolving your Windows container ecosystem, which is supported only for newer version of Windows, including Windows Server 2019. So really, it's just looking at you're kind of still using the ability to do containers, but you're still stuck with a framework or a runtime that's only got a limited lifespan on it. Next option really you've got the ability to re-architect. So that's where you're looking at taking your .NET Framework application and moving it to .NET Core. And then you can receive the full benefit of the OpenShift, because now you can run it within Windows, Linux containers or Windows containers. And then I guess the migration effort involved is a little bit more, and it's a little bit more time consuming, but the option's there to do it. And then you've got rebuild, so that's where you're taking your cloud native apps and you're deploying it to Red Hat or Red Hat CoreOS containers. So the full benefit of containerization is then you achieve the same thing as if you re-architected. But net new development may not be an option for customers. So I guess it's talking about re-architecting what you've already got by migrating from .NET Framework to .NET Core, or actually just building in a full cloud-native way using newer methods. So one's obviously, all of these have a different trade-off, a lot more technical debt, and a lot more time, time-consuming from a customer's point of view. So that's where the OpenShift platform gives you those options. Now you can choose which one suits the customer the best. Cool, so this is getting a little bit more technical with the OpenShift. So really, it's all controlled through what's called the Windows Machine Config Operator. So this is available on Operator Hub within OpenShift. So the Windows Machine Config Operator is the entry point for OpenShift customers. So you install the operator, and it's really about a day two operation. So allowing the cluster admin to add Windows worker nodes as a day two operation with your prescribed configuration to the installer, and enabling the scheduling of those Windows workloads on it. So it's not really a out of the box thing. You've still got to install an operator, and the administrator has to do some pieces to get those Windows machines running. But it does then allow OVN hybrid. So that's your open virtual networking that's built into all of the way that the pods and the containers talk to each other. It allows to use that alongside your for your virtual Kubernetes network. So I guess the way that this works, so if a cluster admin was going to install this, the first thing they do is install the operator and get it configured. Once that's installed, then they receive some benefits of some pieces that make up the overlay for the Windows nodes. But then the cluster admin has to go and create what's called a Windows machine set. So just like a regular machine set in OpenShift, you create one that's specifically targeted at Windows workloads, and you say what tag within that machine set that the OpenShift operator is looking for. So in this case, it'll be a tag called Windows. Then what happens is OpenShift, or the Windows Machine Config Operator, looks for that machine set, looks for that tag. It finds the container image that you're looking for, and it goes and generates a Windows node. So using the Microsoft's CoreOS, which we'll cover a little bit more in a minute. Once that's done, it's created that virtual machine, and then the Windows Machine Config Operator then configures that machine to be able to run pods and containers. So it runs a bootstrapper, which enables container native interfaces, kubelets, and a few things, and a proxy, so that way it can come under the networking of the overall OpenShift platform. So it's a little bit convoluted, but essentially the 2 steps that the cluster admin needs to do, well, 3 steps, is install the operator, create a machine set, and then configure a gold image or an instance of Windows that it can use to generate new nodes. So once those 3 steps are done, OpenShift takes over the rest of running that image or that node. So once that node's detected, it transfers the binaries to it. So once that Windows node is configured and it's created, it transfers over some binaries for bootstrapping. It configures it, so it runs that Windows machine bootstrapper. Oops, sorry. It does a hybrid overlay, so that's just around networking to make sure that it's pulled into the same method of networking as the rest of OpenShift for any pods that you're running on there. And it configures the container network interface as well. And then finally, it just allows a proxy for that outside communication. So that's really talking about if you're running a web server or something in .NET pods, you can actually have access out from outside into that container. So it's kind of a 5-step process of what it does to the Windows node once it's configured. So the supported platforms at the moment, so at the moment it only supports Azure and Amazon Web Services, and recently vSphere was added as well. So really it's talking about having either a gold image in the case of Azure or Amazon for Windows, or in vSphere it's talking about a templated VM. And then what it does is it can deploy that worker node and then start running pods and containers on top of it. And as you can see with Q2, we're looking at Red Hat's looking at offering the bare metal pieces around that as well. So when the bare metal comes in, that's where you're going to have a lot more of a case of saying, well, once you've got the platform, you can either run Windows native containers, or you can have virtual machines running, Windows virtual machines running on the same platform as well. And then in the future, they're looking at things like Red Hat virtualization and OpenStack and a few others. It just comes down to, I guess, how much need there is and demand there is for it. So the way that it works is that you install the operator. Once the operator has been installed, then the cluster admin will go and configure a machine set looking for a specific label. In this case, we'll say it's a Windows label. And then the operator will do all the necessary steps to configure the underlying virtual machine. And that machine set then is a way to initiate the process. So you can go and ramp up more Windows nodes if you need more availability for the underlying platform. So you might fill up one node with containers. You can quite easily with your machine set go and update it to 2. It'll deploy the new Windows node. And it usually takes about 15 minutes for the operator to actually go and configure the worker node. And then once it's in a ready state, then you can start deploying your workloads to it. Updates, essentially a newer version would be if a new version comes out for the operator. Basically, it checks to see obviously if the versions are the right ones or not. It pulls down the new version. It then reconciles all the usual type of way that OpenShift upgrades each operator. So each of them is given an annotation indicating which version is on them, and then it's configured. Then it verifies the annotations. Each Windows node is checked for the config operator, and the instances are deleted and updated one by one. So essentially, if you've got 5 or 6 different nodes, it'll take each one down and upgrade it. And then the replacement machine is created by the machine API, and this will repeat until all of them are being replaced with the newer versions. So essentially, it's talking about, it's really about that upgrade of OpenShift. When you're moving between different versions, it normally goes and updates the underlying core OS as well as everything that's all the operators that are running on it. It's essentially the same process for Windows, with the exception of the actual image itself. So the cluster administrator has to provide a new Windows image while creating VMs. So if a new image comes out, the cluster admin is actually responsible for pulling down what that new image Windows image is, and you just jump into your machine set and change the image name. And once it's changed in the machine set, then it will go and the same process will happen. It'll take down the existing ones and re-implement them one by one. So some of the benefits, so it's an automated approach to make Windows nodes join the OpenShift cluster. So once you've got that image in place or that templated VM, OpenShift takes care of the rest. It uses OVN networking. And just a little note there's a few of these that have got a work in progress note against them. So these have had the initial sort of steps done in the platform, but they're not fully integrated, if that makes sense, which you'll see in a minute when we go through the demo. There is some stuff that's not quite there yet, but it is something that Red Hat's continue iterating with each release. So things like not all the logging and monitoring is available. You're not always be able to see everything in the console that you can with Linux nodes, but you can see that it's there and you can deploy workloads to it, which is what the first version is all about. So that's kind of where that's sitting. So let's jump into .NET workloads on OpenShift. So what operating system to target with .NET containers? So if it's .NET Framework, they have to be run on Windows Server containers. So that's really your .NET 4s and below. With the release of, and then obviously you've got .NET Core in there as well. So .NET Core is your multi-platform supported version of .NET. So you can run that on Linux itself, or you can run it on your Windows containers. With the latest version of .NET, it's literally just called .NET, and the idea with it is as a replacement going forward for .NET Framework and .NET Core. So Microsoft labeled it .NET 5, and essentially that is the future, or moving forward, it's all just going to be .NET. But I guess at the moment the adoption of that hasn't been huge, but obviously people are slowly moving code over towards the new .NET 5. But the idea with this is that your .NET Framework applications are actually going to be eventually going to be just legacy, and they're not going to be supported anymore once it reaches a certain point. So using .NET with Windows containers, so choosing which one to use, Microsoft has some recommendations, which is on that table on the left there, but you can go and see that yourself under the architecture for containerized .NET applications on Microsoft's website. So it's worth taking a look if you weren't too sure, you wanted to tell your customers what they should be using. So there's a bit of a decision tree for targeting .NET container workloads. So if it's .NET Framework, you've got a couple of different options. If it's a compatible version with Windows Server 2019, You can then use OpenShift with Windows containers and deploy them to Windows nodes. If it's an incompatible version, so that's normally an older .NET framework, then really you want to be looking at porting to .NET Core. There's no point sort of upgrading to a later .NET if it's incompatible, and you're going to have to do the same process to move to Core anyway. And then once you've actually done that, then you've got the ability to run it on Linux or Windows. If the application is already .NET Core, you've got that you've got that cross-platform support with Windows nodes and Linux nodes as well. Thankfully, there are a few applications that can kind of help. So if you're looking at a customer's application or the customer's not too sure, there's a few extensions you can use for Visual Studio. And these are, or there's a console app or there's a Visual Studio extension. So the idea is you load your project up and you actually run an analyze process, and it spits out a report which tells you how close it is to being able to support either any version of .NET. So in this case, if you've got a .NET Framework application and you wanted to check how close it is to using .NET Core, this will spit out what sort of percentages you're looking at of the current code that actually supports the framework you're interested in. So in this case, you can see the example that we've got here is it's looking at .NET Framework, and it's got .NET Core there, so it's 71% of the way there. So there's probably a few different classes or libraries that need to be ported over to .NET Core, but most of the work's already there, or the support's already there for it. So quite handy if customers aren't too sure and they're not sure how much work they have to do. This is a good way to kind of work that out. Cool, competitive differentiators. So really just looking at Red Hat OpenShift versus some of the competitions that are out there. So really it's about support for numerous platforms with Red Hat. You've got the ability to support 2 clouds at the moment, and there's incremental support plan for vSphere and bare metal coming forward. vSphere has actually just been released, but bare metal, Red Hat virtualization. So the scale of where it can be supported is a lot more than other providers that are out there. And it provides an operator-based experience. So really it's about the operators that are built into OpenShift. So it's about provisioning new worker nodes, machine API for auto scaling, which is coming. That's not there at the moment fully, but you can obviously auto scale based on load. With Windows, with the Linux nodes, you'll be able to do the same thing with Windows nodes as well. And it's about that automatic and rolling upgrades and lifecycle of Kubernetes. So it's got all of that baked into it. The UI UX is arguably better with OpenShift as well. It's really about that hybrid and networking based OVN as well, and automation. So automation of service and route creation for containers, as part of the user flow from Web Console or even within the CLI. All of that's available because of what's part of the OpenShift platform. I guess the reason why like OpenShift is a little bit behind in Windows support compared to say Rancher is more just Red Hat wanted to bake it into the platform 100%. So they started with the initial stuff that you'll need to actually be able to run containers, and they'll just ramp it up from there. But the initial support had to fit in with the rest of the OpenShift platform and how it works for it to actually sort of make sense to do it in the first place. Otherwise, you kind of just bolting things into something and it doesn't work quite as well. So this next slide, this is a little bit salesy. So Red Hat has a kind of mentality of, clouds that compete can still connect because our code is open. The idea being that, OpenShift can run anywhere, and it's the same process, it's the same platform, the same features that are available in most cases. But the idea is that you're building for one platform rather than spending time building into one of the cloud providers specific platforms. You can lift and shift. It means you're not locked in, and you can have it running across, multiple different clouds, potentially based on geographical location, could be based on pricing or deals and things as well through those providers. So Red Hat really is all about that cross-platform. Cool. So where we're up to now is we're up to our first quiz. So what I'll do is I'll just quickly post the link to the quiz in the chat. So just take your time, go through the quiz and answer the questions that are on there. It's all based on the content we've just covered. So hopefully you've been listening. But the quiz is then what we'll do is we'll take that and draw a winner from the hat once we've got all the correct answers and responses in there. So I might just give you a couple of minutes just for people while it's fresh in your minds to go and complete that. Cool. Might just carry on. into the roadmap stuff. Feel free just to complete it in your own time. As I said, I won't do the draw till tomorrow, so you got plenty of time to answer the quiz. So looking forward at the roadmap. So at the moment, there's the pieces that are generally available as basic config. You've got your machine set for the API. You've got support for AWS, Microsoft, and vSphere. It's delivering Kate components, patches, and updates. And then looking forward, I guess in the next sort of quarter or the next 6 to 9 months, looking at support for things like bare metal, Red Hat OpenStack, and virtualization, all that monitoring and login solutions that need to be sort of fleshed out a little bit more. They'll also look at doing a bit more hardening around it, and also a strategy around CVEs and fixes and things too. So they're also looking at the ability to auto scale Windows nodes as part of the next round. So really, your Red Hat's kind of just iteratively building more features in each release that they have. And also some level of performance testing that it needs to be around it as well. I think with the OpenShift platform, the performance testing has been done in terms of talking with the Windows node. It's just making sure that Docker and everything's maintaining performance on the Windows node itself. And then long term, it's really looking at supporting for hosted platforms of OpenShift. All the Knative service mesh pipeline stuff that at the moment is part of Linux containers and OpenShift. It's looking at bringing that in for the Windows support as well. And also support for multiple images across operating system types too. So at the moment, it's really down to the images that you're using when you deploy a container. For the Windows nodes, at the moment, it's running Windows containers, but potentially you could be running different operating system types within those nodes as well in the future. Could be down to running a Windows container with an OpenShift on a Linux node potentially as well. I know Red Hat have been looking into that a little bit as well. So just some of the limitations. So we've covered some of these already. At the moment, it's missing sort of the serverless and service mesh stuff. Looking at your source to image and build configs, it's not fully built in there at the moment. So at the moment, it's kind of expecting you to build these containers outside of the platform. So through your current build processes using Docker. But once it's built, obviously you can use that in your registry and actually pull it in as a deployed node to the Windows server. It's not a built-in Windows operating system into the platform. You've obviously still got to bring your own Windows license for it as well. So that's another kind of limitation, and I don't think that's going to change unless Microsoft and Red Hat do a deal in the future. You're still going to have some sort of license from Microsoft for the nodes. So the way that I guess the Windows containers are priced, so you're looking at the full control plane for OpenShift. So that's your fully licensed OpenShift. So you've got to obtain your subscription for Red Hat for that. Now for the Windows machine config operator, there is a subscription you've got to get for Red Hat for that one. I'm not too sure on the pricing around that. I don't know how much it is, or if it's an add-on, or if it's just an enablement SKU. But that's something I'll probably follow up with and after this, just to give a bit more information. I believe it is a subscription you have to purchase from Red Hat on top of the OpenShift control plane. OpenShift being the base support for the platform, and then supporting the Windows nodes that you're running this infrastructure on it's probably going to be an additional cost. And then obviously from a Microsoft perspective, you've got to have a subscription or a license for your Windows operating system as well. So there's a few things to consider if you are selling this to customers or looking at promoting it as a potential solution for what they're looking to do. Cool, and now we're up to the demo. Before I start that, is there any questions so far? Anything that's not too clear? Cool, I'll take that as a no. Okay, so let's jump into the demonstration. So I have a terminal set up. I've connected into a demo environment. So on this particular environment, we have a full OpenShift instance and all the client tools that we need. So if I wanted to say, for example, check which nodes I've got running at the moment within this platform, I can see that there's 6 nodes in total. So what we're assuming here is that 2 of them are Linux-based nodes and 1 of them is a Windows-based node for the workers. Now, if I wanted to specifically see which one of them is running on as a Windows node, I can do a wide command. So using wide, I can actually see a fair bit more about each node. If I just zoom out, Because it's wide, obviously, it's a lot more to see. But you can see here that this one in particular says it's a Windows Server 2019 data center. That's the OS image. And you can also see the container runtime on the right. There's Docker, as opposed to using Cryo with the Linux nodes. Let's zoom back in so everyone can see. So that's kind of how you can see then which nodes you've got there. And then if you wanted to have a look through the web console, so within the web console, first thing you want to look at is the installed operators. So in this case, we can have a look and we can see we've got our Windows machine config operator installed. It's a bit of an introduction, bit of a blurb, and then there's some usage and just some config there as well. So if you are going to deploy this to OpenShift, just take a look at the config, because you've also got to then go and set up your machine set for it as well. So this gives you a bit of an idea, depending on the platform, what you need to do to get the Windows nodes running. So if we want, we can then run down and actually have a look at our machine set that's been configured. So we've got our standard ones for our Linux nodes, and they're all been set up to run on three different locations within AWS. Or we can have a look at our Windows one there as well. So if we jump into that, we can see we've currently got one machine. If we want, we could scale that to 2 or 3 machines, and it'll go and create replicas of that Windows node. And then they'll be scheduled the same way as you do with other deployments in OpenShift. It'll put pods on each node to spread the load. We can have a look at the configuration as well, so we can have a look at the YAML. So obviously there's a lot of stuff in here that's probably not so relevant. But one thing, if you wanted to have a look for your the image name, you can see that in here, and you can also see things like your instance type, depending on if it's Azure or AWS. You can see what type of instance it's recommended as well. So you can change this, you can fit this based on whichever EC2 instance type that you wanted as well as part of your machine set configuration. If we want to have a look at what machines are actually running, so we've actually got 2 here, and this is where it can get a little bit confusing, because OpenShift needs a bunch of the platform pods to be able to run the Windows node. It'll say which Linux node those pods are running on as part of the control plane. So as you can see here, we've got one of our Linux workers being used, but we've also got our Windows one there as well. So this is kind of in addition to the Windows node, you've got to have this Linux node on the side for a few things, which we're going to cover off now actually in the demo. So one of the things that is provided as part of the platform is a pod running on the Linux nodes, which allows SSH into the Windows nodes. So you can see here we've got a pod running on one of our Linux machines, and we can use that now to connect into the Windows node as well. So if we connect to that pod, which we can do using a simple command, we can RSH into it. We then get a bash terminal within that pod. Once you're on there, there's actually a nice handy script that's provided to make it easy to then SSH into the Windows box. So if we paste this in and we hit enter, it instantly gives us then a PowerShell on that Windows node. So I've now got access to the Windows node. I can run all the standard Windows PowerShell commands. So the first thing we'll do is actually we'll have a look to see if Docker's running anything at the moment. So we can see there's no containers, nothing's running on Docker within here. If I want, I could then go and check all the processes that are now running on this Windows node. So what we're looking for specifically is Kubernetes overlay or Docker tags within the process name. And we can see we've got our Docker service running. We've also got our hybrid overlay, our kubelet, and our kube proxy we spoke about before. So these are the fundamental pieces that OpenShift's installed on this machine so it can start running pods. So that's kind of what makes up our platform on that Windows node. We can check what images we've got available for Docker as well. So as you can see, we've got Windows Server Core, long-term support 2019. So that's nice. It's all ready to go. So we can actually start spooling up now containers and pods on this particular Windows node using that same image. If we wanted to, and that image didn't exist, or you wanted to pull a new version of it, essentially you've just got to do a Docker pull to whatever version of the image that you're looking at deploying as your container image. So in this case, if we try again, it would just say it's already up to date. Cool, so I'll exit out of this and we'll go back here. And then what I'll do is I'll quickly show you if we're going to deploy an application to this now as well. So we've got a YAML which kind of defines our deployment. First thing it actually does is creates a service. So with the way that OpenShift works with Windows containers, you've got to create a service for each application you're running, and then it allows you to be able to connect into it if you want to open up a route to the outside. It's essentially that kind of first step. And in this case, we're looking at a load balancer service for this Windows web server that we're going to now start running. The second piece that we have then is the deployment. We can see what the app is, what we're calling it. We can see a few labels and things. We can see what image it's requiring to be used as well. And we can also see then it's going to a Kubernetes IO OS window. So it's saying that it needs to be a Windows node. So that's your node selected down the bottom. What this is actually doing is just going to run a command through PowerShell to create a very simple HTTP listener. So it's nothing too major. It's not a full application or an existing Windows image that has the application built into it. It's just we're just going to have a command run to create a simple web page on here. So if we jump back over to our command line, so I guess for the purposes of this demo, we're going to be deploying to the default context, the default project or namespace in OpenShift. Typically, what you do with all your projects and your deployments is you put them into a specific namespace or project, if you want to call it that. But in this case, because it's running in for each Windows namespace or project you want to create, you've got to turn off the security context constraints. So once they're disabled, because they only apply to Linux-based workloads, then those namespaces should only ever be used to run Windows containers from then forward. So i.e., don't mix your Windows and Linux workloads within the same namespace because Linux pods will not have the correct security context. So it's a limitation at the moment because the security context in OpenShift doesn't apply to Windows nodes. It's only about the Linux nodes. But once you've created that namespace, you can turn off that context and you can run it under whichever namespace you want. We see deployments are typically, the namespace or project will start with Windows. That way you can differentiate your Windows loads from your Linux nodes as well. So if we want to deploy that now, we can create, run that same YAML file we just had a look at. So now it's gone and created the service and it's created the deployment. So we can go and check out what nodes that we've got. So we can see that at the moment the Win web server container is currently creating, so it's not ready yet, but we can sit there and watch it until it is ready. It should be any second now. There we go. So now that the container is running, we've got a Windows web server running on the Windows node with a Windows container. What we can also do, we can check and just have a look at the toleration that's been created for this particular pod to make sure that it's running on a Windows node. So we can run a get deployment for the web server and check the toleration. So we can see here that the key is OS and the value is Windows. So we're just making sure that pod is specifically set it can only run on Windows. And then again, we can actually do a pod check, but this time we're going to do a wide pod check so we can see which nodes it's running on. And we can see there we've got a Windows web server and we can see it's running on the Windows node. So if we want, we can connect back into that Windows node again. So we're going to get back in there. We're going to run our SSH to get back onto the node. Now, if we go and check our Docker processes, we can see that we've got a couple of containers now running within Docker. Just scroll out a little bit. So we've got a Kate's Windows web server, and we've got a second one there as well. So essentially it's that PowerShell command that we run before. So now that's running within a container in Docker. So if we exit back out, what we'll do now is we'll just jump into the web console once more. And we can go have a look at our topology page and have a look at what's under default project. And we can see here we've got a Windows web server running now as a pod. And we can see, the service has been created, which is the first thing it did, and then it deployed the application as well. Right now, there's no route, so we can't access that web server right now. So the next step is to expose that route. So we can either do the route through the interface here, or we can do it through the command line. Just for simplicity, I've already got the command here, so I'll run it through the command line. I'll just clear that. So we're just going to expose the service. Now it says that it's exposed. If we jump back into our screen here, we can see that there's a URL now available, so we can click on that and access the web server. So the route's now available. You can see the web page. Now, if we wanted to, because that pod's now running on Windows, if we wanted to, we can actually connect directly into this pod that's running this web server now as well. So that's handy for things like debugging or if there's been a failure or something as well. So very simple. It's a matter of choosing the pod and choosing an option PowerShell. And it actually gives you straight access to that pod directly now with PowerShell access. So if we want, we can do a task list or a process, or we can have a look what's running. In this case, we can do task list. We're looking for a specific pattern in HTTP, and that then just shows us that we've actually got we've got an application now running on this pod that matches that description. To bring that application down, it's the same as every other program in OpenShift. If we wanted to, we can go on and delete the pods, delete the deployment for this particular application as well. So under here, for example, we can go workloads, pods, default. We can delete the pod, it'll spool up another one if it's failed, or we can go and actually delete the deployment so it never deploys another version. We can also scale up too, so we can go and create more replicas of the same pod quite easily just by increasing this. And now we've got 2 versions of the same pod running, nice and simple. And I guess that's about it. I'll just show you one more thing. So when you're having a look at the nodes themselves and looking at what resources is being used within each particular project, if we go into our default project here, we can see we can't see any current metrics around how much CPU memory is running. So this is the piece that's coming in the next version of OpenShift. Right now, you can't see some of those metrics for each, for each pod or each node that you've got that's running Windows. It's not there at the moment, but it is the thing that Red Hat's working on, better integration with the interface here. And that's essentially the demo. Cool. So really, next steps, there's a web page you can go and have a look at, openshift.com/learn topics Windows containers. So if you want to read more about it, where Red Hat's going, what type of workloads you can run on there, maybe some examples and things, check that out, and it gives you a bit more information around specifically what's been built into OpenShift and OCP for Windows containers. Cool, and the reason why everyone's stuck towards the end, the survey. So again, I'll post this link into the chat. So just complete the survey in your own time. And yeah, we'll do the draw tomorrow. I see there's someone has lost the link to the quiz. I'll repost the quiz link in there as well. So those are the 2 links that you want. Cool. So that's essentially it. If there's any questions, now's probably the time to ask, and I'll just check back through the chat to see if there are any. Alistair. Oh, right. Yeah. Okay. Yeah, Visual Basic 6. I guess in theory, if the Windows container, the CoreOS supports running Visual Basic, then I'm sure it would work. I don't know how much support's actually built in into the Windows CoreOS. So I guess that comes down to whether or not Microsoft support it with that particular image. I have a feeling that most of your Windows type processes will work. And as part of your deployment process, you can obviously install additional runtimes and things on that Windows container. So it'll be a matter of looking at how you actually build using Windows CoreOS, how you build a container from the image. So I'm guessing you'd pull the image and you'd probably pull in a few runtimes, and then you could run VB or some of that older legacy stuff as well. I guess if any questions do come up or you've got a customer that's interested, just let us know. You can get in contact with us directly, or you can visit the microsite as well. We'll have a bit more content put on there around Windows containers, and this should be available on demand as well if you want to take a look at it again or show it to some of your staff.